Hello and welcome to Onkmat Online Academy. In today's lesson, we want to continue with our discussion on laws of motion. In our last lesson, we talked about the first and second law of motion, and we also talked about the third law of motion, impulse, momentum, and law of conservation of momentum. We have also talked about elastic and inelastic collision, and today we want to look at the application. We want to look at the application of the third law of motion. Application of the third law of motion. The third law of motion is applied in rocket propulsion and recoil gun. Now, how is it applied? For a rocket to move during launching of a rocket, hot gas is blown out of its back, and the hot gas brings a force that moves the rocket forward. So that is how the rocket is propelled forward. By pushing out gas from its back, the rocket is propelled forward. Now, in recoil gun, it is a common experience that when someone shoots a gun, there is always this impact or force coming back on the person shooting the gun. That force is called recoil force. Now, what happens is that the force of the bullet moving out from the gun will create equal but opposite force that will come back and have an impact on the shooter. Now, the force of the bullet moving forward is called propulsive force, while the force coming back to the shooter is called a recoil force. There is a relationship between the propulsive force and the recoil force, which is determined by the momentum of the gun and the momentum of the bullet. And the relationship is that the momentum of the gun is equal to the momentum of the bullet. Now that means that if m is the mass of bullet and m is the mass of gun, v is mass of bullet, and v capital is the mass of gun. If small m is the mass of bullet, big M is the mass of gun, and small v is the mass of bullet, and big V, capital V, is the mass of gun, then we can say that small letter v times small letter m is equal to capital M times capital V. This creates a relationship between the momentum of the gun and the moving bullets. Now let's look at some examples where we can use this to calculate either the velocity of the bullet or the velocity of the recoil force. Now in this example, find the velocity of recoil of a gun of mass 5 kg from which a bullet of mass 10 gram is fired at a velocity of 250 meters per second. Now what do we need to do? We know that the relationship between the recoil force and propulsive force is now we know this is the mass of the bullet and this is the velocity of the bullet. This is the mass of the gun and this is the velocity of the recoil force. Now we are looking for this velocity of the recoil force. We know the mass of the bullet as 10 gram. Why this one is in kg? That means that you are going to convert the 10 gram to kg. 10 divided by 1000 is equal to 0.01. So we have 0.01 times by velocity of velocity of the bullet is 250. Mass of the gun is 5 kilogram. So 5 times V, 5 times capital V. Now we have that V is equal to 0.001 times by 250 divided by 5, which is equal to 25/5. Now this gives us 5 meters per second. So the velocity of the recoil force is 5 meters per second. So this is how to calculate velocity of the recoil force from the relationship that exists between the propulsive force and the recoil force.